Smart Culture Science.
In this video, we'll discuss how to go about determining the limiting reagents of a chemical reaction. Let us first talk about what exactly a limiting reagent is. The limiting reagent in a chemical reaction is a reactant that is totally consumed when the chemical reaction is completed. The amount of product formed is limited by this reagent since the reaction cannot continue without it. Why do you think it is important to determine the limiting reagents of a chemical reaction? The following little story will demonstrate the significance of limiting reagents. Let's say John wants to build cars. In order to assemble a car, 4 tires and 2 headlights are needed. In this specific example that we are dealing with, suppose that the tires and headlights are reactants, while the car is the product produced from the reaction of 4 tires and 2 headlights. If John has 20 tires and 14 headlights, how many cars can John build? With 20 tires, 5 cars can be produced since there are 4 tires to a car. With 14 headlights, 7 cars can be made since only 2 headlights are needed per car. Even though more cars can be made from the 14 headlights available, it's only possible to make 5 full cars because of the limited number of tires available. In this case, we have a surplus of headlights while the tires are the limiting reagent. Now let's move on to real chemistry and discuss how to go about determining the limiting reagent. So the first step will be to determine the balanced chemical equation for the chemical reaction. Step 2, convert all given information into moles. Step 3, work out the mole ratio from the given information. Compare the calculated ratio to the actual ratio. Step 4, use the amounts of limiting reactant to calculate the amount of product produced. And the last step, if necessary, calculate how much is left of the non-limiting reagent. I know this sounds very complicated, but it's not. Let's move on to an example question. Determine the limiting reagent if 75.5 grams of tribromoethane were reacted with 47.1 grams of oxygen. The first thing that you should do is to write down the balanced chemical equation for this chemical reaction. Tribromoethane reacts with oxygen to produce carbon dioxide, water, and bromine. The next step is to convert all given information into moles, most likely through the use of molar mass as a conversion factor. Let's start with that. 75.5 grams times 1 mole over 266.72 grams is equal to 0.283 moles of tribromoethane. 47.1 grams times 1 over 32 grams is equal to 1.472 moles of oxygen. Assuming that all of the oxygen is used up, 1.472 times 4 over 11, or 0.535 moles of tribromoethane are required. Because there are only 0.283 moles of tribromoethane available, tribromoethane in this case will be the limiting reagent.
For online tutoring or additional resources, visit our website www.smartculture-education.com.
Subscribe down below. It's easy.